In global geopolitics, air superiority is the ultimate power move. The old measure was speed and firepower, but now, invisibility is the real game changer. Stealth technology lets jets fly undetected, gather intelligence, and strike before the enemy even knows they're there. It renders expensive enemy radars and missile systems nearly useless. For India, surrounded by complex threats, stealth isn't a luxury, it's a necessity. The doctrine is simple. First look, first shot, first kill. Stealth pilots can detect and engage enemies before being seen, drastically increasing survivability and mission success. The global race for stealth fighters is about strategic autonomy and technological prowess. That's why nations like the US, China, and now India are investing billions to master aerial invisibility. When we talk about stealth technology in the context of fighter jets, it's easy to conjure images of complete invisibility. But the reality is far more nuanced. Stealth isn't about being invisible to the eye, it's about being invisible, or rather, less visible to sensors, especially radar. It's about minimizing the chances of being detected in the first place. Conventional jets reflect radar like a mirror, sending strong signals back to the source. This makes them easy to spot on radar screens, giving away their position, speed, and direction. Stealth jets, on the other hand, are designed to scatter or absorb those signals. They employ a range of techniques to reduce their radar cross-section, making them appear much smaller, or even disappear entirely from radar. Their unique shapes, flat surfaces, sharp angles, are not just for aesthetics. They are carefully calculated to deflect radar waves away from the source, preventing a strong return signal. It's like skipping a stone on water, redirecting the energy instead of reflecting it straight back. But it's not just about shape. Advanced radar-absorbent materials, or RAM, are applied to the surface of stealth jets to soak up radar energy, converting it into heat. This combination of shape and material shrinks the jet's radar signature to that of a bird or even a marble, making it incredibly difficult for radar systems to detect and track. True stealth goes further, masking heat signatures that infrared sensors could pick up. It also minimizes electronic emissions, preventing detection by specialized equipment, and even reduces sound to avoid auditory detection. Engines are buried deep within the aircraft's body, and exhausts are cooled before being released into the atmosphere. Furthermore, special systems minimize electronic footprints, ensuring that the jet doesn't give away its position through its own signals. Every detail, from the composition of the canopy to the design of the weapon bays, is carefully considered. Every aspect is optimized to make the jet a ghost on the battlefield, a silent predator lurking in the shadows. This multi-layered approach, combining shape, materials, and systems, makes detection, tracking, and targeting extremely difficult, even for the most sophisticated air defense systems. Stealth, therefore, is the art of disappearing in plain sight, not by being invisible, but by being exceptionally difficult to see. It's a constant game of cat and mouse against the world's most advanced defenses, pushing the boundaries of engineering and technology. India's AMCA project marks a bold shift, a testament to the nation's growing technological prowess and ambition in the aerospace sector. This initiative represents a significant leap forward in India's quest for self-reliance in defense manufacturing. From importing jets, a long-standing reliance on foreign technology, to building a world-class stealth fighter, a symbol of indigenous innovation and engineering capability. This transition is not just about acquiring new hardware, it's about fostering a culture of innovation and technological independence. It's a national mission, driven by the highest levels of government and supported by a dedicated team of scientists, engineers, and defense personnel. The project is a matter of strategic importance for the country, placing India among the elite few, nations that possess the technological know-how and industrial capacity to design, develop, and manufacture advanced stealth fighter aircraft. This achievement would significantly enhance India's standing on the global stage. US, Russia, China, countries that have already demonstrated their capabilities in stealth technology, setting the benchmark for others to follow. India aims to join this exclusive club, showcasing its own unique approach to aerospace engineering, capable of such technology, pushing the boundaries of what's possible in aerospace engineering and materials science. Stealth technology requires a deep understanding of aerodynamics, radar cross-section reduction, and advanced materials. The Aeronautical Development Agency, DRDO, and HAL, the cornerstones of India's defense research and development ecosystem, are leading the charge, pooling their expertise and resources to overcome the technological challenges inherent in developing a fifth-generation fighter aircraft. Building an ecosystem of aerospace innovation, fostering collaboration between government agencies, private sector companies, and academic institutions. This collaborative approach is crucial for driving technological advancements and ensuring the success of the AMCA project. AMCA is designed for air superiority, ensuring that the Indian Air Force maintains a decisive edge in aerial combat scenarios. Ground strike, delivering precision strikes against enemy targets with minimal collateral damage. And electronic warfare, disrupting enemy communications and radar systems, providing a critical advantage in modern warfare. Covering the full spectrum of modern combat, making it a versatile and indispensable asset for the Indian Air Force. The project will roll out in 2 phases, a strategic approach to mitigate risks and ensure a smooth transition to full operational capability. Mark 1 with a proven engine, minimizing development risks and accelerating the initial deployment of the aircraft. And Mark 2 with a next-gen co-developed power plant, showcasing India's commitment to indigenous engine technology and international collaboration. The design is complete, incorporating cutting-edge technologies and advanced aerodynamic features, and prototypes are on the horizon, marking a significant milestone in the development process and paving the way for flight testing and evaluation. The journey is a marathon, requiring sustained commitment, perseverance, and a long-term vision, testing India's scientific and industrial limits, pushing the boundaries of innovation and technological capabilities. Success will redefine India's status, solidifying its position as a formidable air power, capable of safeguarding its national interests and contributing to regional stability. AMCA's fifth-generation status comes from its advanced stealth and smart technologies. Serpentine air intakes hide engine blades, while carbon fiber composites and radar-absorbent materials slash radar visibility. Weapons and fuel are carried internally, preserving stealth in combat. Sensor fusion combines radar, infrared and electronic warfare data, giving pilots a unified real-time view of the battlefield. The cockpit features panoramic touchscreens and helmet displays, letting pilots lock targets with a glance. Supercruise, sustained supersonic flight without afterburners, gives AMCA speed and range advantages. These features make AMCA a dominant force, ready for the battles of tomorrow. It's not just a jet, it's a flying supercomputer built for the future. India is already looking beyond conventional weapons, developing high-energy laser systems for future air combat. DRDO's laser research aims to equip fighters like AMCA with defensive and offensive laser weapons. Defensive lasers could instantly destroy incoming missiles, offering a new level of protection. The goal is to scale up from kilowatt-class to 100-kilowatt-class lasers, enabling both defense and precision attacks. Ground-based systems have been tested. The next step is miniaturizing them for aircraft. Power, cooling, and targeting challenges remain, but India is determined to lead in this next-gen technology. Laser weapons could soon redefine air warfare, giving India a decisive edge. Embarking on the journey of building a stealth fighter and integrating advanced laser weapon systems is no simple task. It represents a monumental undertaking, pushing the boundaries of engineering and technology. It is a massive, complex challenge, demanding precision, innovation, and unwavering commitment at every stage of development. Securing and sustaining funding is paramount. Funding must be sustained over decades, requiring careful financial planning and unwavering political support. Furthermore, mastering stealth shaping, the art of designing an aircraft to minimize its radar signature, developing advanced composites, the lightweight yet incredibly strong materials that form the aircraft's structure, and integrating cutting-edge avionics, the electronic systems that control and navigate the aircraft, is no small feat. Each of these elements presents its own unique set of technical obstacles. Perhaps the biggest hurdle is engine technology. Developing high-performance engines with the necessary thrust and efficiency is incredibly difficult. Few nations have succeeded, highlighting the complexity of this technological challenge. This makes international co-development crucial for AMCA Mark II, allowing for the sharing of expertise and resources to overcome these technological barriers. Globally, AMCA will inevitably compete with established platforms like the US F-35, a formidable and proven stealth fighter, and China's J-20, another advanced stealth fighter that represents a significant technological achievement. However, AMCA aims to balance stealth, not solely prioritizing it above all else. Agility, ensuring the aircraft is highly maneuverable in air combat, and advanced systems, tailoring the aircraft to meet India's specific operational needs and strategic requirements. India can learn valuable lessons from others' experiences in developing advanced fighter aircraft and potentially leapfrog ahead by incorporating newer, more advanced technologies into the AMCA design. The current target is to have the first prototype ready within a few years, marking a significant milestone in the program. Following successful testing and development, service entry is projected for the early 2030s, bringing the AMCA into active duty. Ultimately, success depends on synchronized and collaborative efforts from the government, providing the necessary policy support and resources. DRDO, the Primary Research and Development Organization, ADA, the Aeronautical Development Agency, responsible for the design and development, and HAL, Hindustan Aeronautics Limited, the state-owned aerospace manufacturer responsible for production. Overcoming these multifaceted hurdles will undoubtedly test India's resolve and engineering prowess, pushing the limits of what is possible. But it is a challenge worth undertaking, as it will ultimately shape its own future in the skies and solidify its position as a leading aerospace power. AMCA and laser tech are more than military projects. They're statements of India's ambition and self-reliance. Building indigenous fighters reduces dependence on foreign suppliers and strengthens national security. With two nuclear neighbors, India needs credible deterrence and the ability to project power. Directed energy weapons promise new ways to defend and strike, changing the rules of aerial combat. These projects drive innovation, create high-tech jobs, and boost India's global standing. AMCA's success could open export markets and establish India as a leader in advanced engineering. This is about building confidence, capability, and a nation that controls its destiny. As AMCA prepares for flight and lasers near deployment, India enters a new era, smarter, stealthier, and self-reliant.